Let me start by making some comments and correction about the statement of the theorem, because what I proved is not exactly that statement, but a slight variation. So let me say precisely this value B is power set of omega 1 is contained in n UP G over G belonging to B such that which is B mass genetic over and what happens is that star UB implies that LUPG models NS is saturated but not clear if star UB implies B models NS is saturated. Okay? And I used this assumption essentially in the two. I used that V model NS is saturated, not that I use B models NS is saturated. So the statement, the correct statement of what I proved is the following. Theorem assume large cardinal class filling, and maybe this is, I mean, not all of it. Essentially in the proof I think I just used that every set of real definables in L of UB is universally correct. And then one star UB plus NS is saturated implies that the theory of H omega 2 epsilon delta 0 NS A belongs to UP is model complete. And the two star UB implies star UB. Okay, so this is, so if this theory is model complete, then you get this version of star UB where you don't know if the non-stationary ideal is really saturated in B. You just know that it is saturated in L of UB G. Okay?
What is star star?
Star star is the statement that this is model complete. So what I proved is if you have this and the net is saturated in B, then you have the theory is model complete, and then the converse is if the theory is model complete, then you get this, but this is not clear if you get it or not. Okay. Okay, now we want to address the optimality of this result. So the point is it appears, even if for us that this is a very natural signature, for a person foreign to set theory, he might say why, or she might say why you choose this particular signature among the continuum many possibilities, or even more than that, because here you have the quantity of predicates given by this step, which is precisely bigger or equal than continuum. Okay? And then why you choose this predicate? I mean, this predicate maybe you can convince the people, but this predicate and those predicates, why you choose them among the possibly in continuum many and more that you could have chosen to get this model completeness large. Also, you always have the possibility to do modelization of a first order theory, and when you do the modelization, you obtain quantifier elimination, which implies model completeness. So this appears to be somewhat casualty. Okay, so I want to argue that it is not a random result. Okay, so what I have to do is so first I want to change the signature. So this is not a recursive signature because I'm adding continuum or plus then continuum predicate symbol. Okay, so let me the following can be proved. I don't give a proof, but let epsilon delta 0 ub equal epsilon delta 0 union RP such that quantifiers of P range in IB and y py if and only y is a tuple of yes. So I take all the formulas where I bound the quantification just on universally per set, and where I prescribe that the realization of the formula is given by Ds. This is not this is a definable set of formulas. Okay, so I have to say for all y, py, if and only if wedge I equals 1 and yi belongs to the omega, and if for all x belongs in py, of course in py it is x must range in IDP. Okay, so these are constraints, syntactic constraints that I can express very simply and give me a subfamily of the epsilon formula. And I declare that this subfamily is now my new atomic predicate that I have to the signature. And then I have to add action saying for all x RPX if and only Px. Okay, with those axioms, I'm making the interpretation of these predicates into atomic formula of the signature. And then one can prove a theorem the following are equivalent for T extending.
It's true as long as y is just a difference of width.
Yes, 2 is just saying I have my formula and I require that I'm interested in the satisfaction of this formula when the tuple is real. So I put it inside the request of the.
But should it be just implies or economic? Why is true economic? Why?
Well, let me say Px and I equals 1 and x I belongs to the video. Is it fine? No.
Because you already said Py is true only if and only.
Well, this I have to add to my axiom. So let's say.
But what what else can we say? It's only. If
No, sorry, yes, you are right. You're right. Yes, like this. Yes. T contains C, epsilon delta 0, B, and S. So I also had for the predicate for the
on top of quantifiers of P and renders something. And ranges.
range. So the formula can only have quantified that range over the
Range.
range over the universe,
Otherwise, it can be
any formula. Yes.
Yeah.
So this is giving me a subfamily of the epsilon formula. A recursive subfamily of the epsilon formula. I have to check that the quantifiers in the formula are representing over LUB and that well, then I will add this action that says I just take the realization of the real that realize the formula. Okay, and the theory is DFT epsilon delta 0 plus all these axioms plus the axiom explaining the meaning of non-stationary ideal plus the cardinal.
Because you have a symbol.
Huh?
Do you have a symbol?
Yes. I expand the.
It's only I don't see it.
No, because here it's just, so let's say epsilon delta 0 UP and S equal epsilon delta 0 UP.
And this UB is not constant. Right?
Yeah. Huh?
And UB is not constant in this language. Or it's just.
No, it's a predicate. And let me also put a constant for omega 1.
This, it's not really important, but anyway, this is a little bit like what we do in technology. We take a model class and then we take it as a term as quantifier in the language. But it wasn't before, we just take a symbol for it, like we take a symbol for this, and then we add axioms into the
That explains the meaning. Yes. So this is going to a definitional expansion of set theory. Okay? And it's a recursive definitional expansion. You have not anything that you cannot check without with a computer. Okay. Then the following. Okay. The following are equivalent, and for C, I2 sentence of epsilon delta 0 UB and S. So one C is let's say let's do it like this. C plus T for all values exist is consistent. Well, sorry, this is not the right. This is consistent for any extending T. The 2 H on the 2 epsilon delta 0 and S are P models C being models of P plus
What is R A TAE?
huh?
Do you mean
Here
TAE or so what is
for all values
Yeah, but
Boolean combination of existential and universal sense.
what is R?
R is any theory that extends T.
Okay, bro, okay.
And 3 C is in the model comparison of R. So now this is a completely constructed formulation of the results. So it says you have a theory. It could just be this theory, which is a recursive theory. Okay, and then you take a Python sentence, and you can well, first of all, the tree says that this theory has a model companion. And what is this model companion? It is given by the Python sentence that are realized in models of, well, actually here I have to be a bit more careful because T could negate, sorry, T for all the C's plus CFC epsilon delta 0 UP NS plus T. Okay. So this part 3, it is saying whatever expansion you take of this theory, it has a model companion. Even if this theory T satisfies TH, it has a model companion. What is the model companion? It is given by, let's say, the models of the universal and existential fragment where Mn++ is true. How do you get those models? For example, you force over T Mn++, which you can do because you have large cardinals. Okay, and then how do I compute this model companion? I just have to go into these models of the universal and existential fragment of T plus Mn++ and check if the I2 sentence C is true in all of these models. And this is another possibility. I just have to check that this C is consistent with the universal and existential fragment of any model of T. Okay, so this is giving now a complete description, which is amenable to be. I mean, there is no ambiguity. Well, for example, a non-Platonist can object to what is this. He can even object to the meaning of this signature because here you have a continuum many predicates. While here, this at least on the meaning of the statement, there is no objection. Then maybe there is objection on the truth, just a formal list of stuff that you can prove equivalent, but without real content. Okay. And now I want to show that if you change randomly the signature, so now in this signature we chose those predicates. Okay? But we could have chosen another arbitrary set, countable set of epsilon formula and declare those formulas to be atomic predicates. And I want to show that you cannot get this type of result for an arbitrary choice of the predicate.
Condition 1.
Yes.
What is this big R?
Big R is any extension of T.
Even inconsistent extension.
Consistent extension.
What?
Consistent extension. Yeah, let me do it.
Reasonable.
So I have to set up, let's say, an abstract terminology to handle this possibility. So first of all, let me recall definition. Even theory T tau for all values equal C belonging to tau C is Boolean combination of universal sentence and T for all values C is equal to C belonging to tau for all values C such that T model C. Okay. And And now, given P belonging to tau, we elect tau P 0, sorry, tau P 0 is equal to tau union, well, let's be more precise. If A containing tau cross 2, tau A is equal to tau union RP, such that P 0 belongs to A, union FC, such that C1 belongs to A. So I decide that I have a predicate symbol which have the same extension as P for the P0 that are here, and the function, column function symbol for the C1 that are here. So I'm expanding the signature and the predicate symbols for certain formula, and the column function symbol for other formulas. And well, let me do it like this. T is tau theory, such that T reduced for all x, there exists just one y, C x y, for all C 1 belonging to A. So I have to put this constraint on the type of A I consider. I just consider which are relevant for a theory T, just those where the function symbol are really unambiguously representable in models of T. Okay. Then every model of T has the unique expansion to the tau I model of T plus for all n. Yes,
So tau is a symmetry,
yes,
but here you have some formulas on side.
yes. I am a bit sloppy, so I say that those are the formulas in the signature tau.
Okay.
Plus for all y. Sorry. C X Y equal F C X. Okay, so I have this process of partial modelization that given a signature takes a theory and adds, well, you can freely add the relation symbol for any formula in the language, but you have to be careful to add the column function symbol, because if this statement is not satisfied, you have problem in giving an unambiguous interpretation of this function symbol. Okay? And now we can check well, yeah, definition given the tau theory T. absolute co-theories. If T for all well exist equal S for all well exist, and S is the absolute model companion of T. If T, S are absolute co-theories, and S is model complete. Okay, so this is a notion slightly stronger than model companionship because you require agreement not just on the universal fragment but on the universal and existential fragment. Okay, so for example, theory of Q plus time 0, 1 for all that exist is different from theory of C plus time 0, 1 as signaled by exist as
You read this for all exist. You say universal and extensive, but it's actually universal or existential.
yes.
Okay.
Yes. Well, the point is that every Boolean combination of universal and existential formula is equivalent to a universal formula, disjunction, and existential. Okay, so you see, these two are not do not satisfy this equality, but this theory, so let's call it T0, and this one as 0, but T0 is the model companion. Well, the point is that T0 for all is equal to S0 for all. So this is what is needed for the model companionship argument. But the two theories have a disagreement on the existential tendency. Okay, so there is not. So what happens? The problem is the following: the model companionship say I start from a model and I go to an existentially closed model by a process of adding existential witnesses. And in starting from Q and going to C, I'm going to make true this sentence. And once I make this true, I will never make it false. Okay? So in this notion, we are ruling out this asymmetry. Essentially, what happens in this case is that if we start from a model of T, we can go to a model of S which is existentially closed. But if we start from a model of S, we can again go to a model of T which is a superstructure. While if you just have this equality, in principle you cannot. So you can start from a model of X, this one, and you go to a model of T, this one, and then you cannot anymore go to a model of S. While in this situation, if you have a model of T, you can enlarge it to a model of S. So that's the difference. Okay, and here you actually get this following is the absolute model. So in the case of the theory, what happens is that the type of model companionship result that occurs are of this type, not of this type. Okay, so I now stick to this type. Definition given down theory T plus for all, well, let's say x, I, p, such that p, I belongs to A has an absolute model companion. And what are these axioms? These axioms, in case of P0, is the statement that the formula P is equivalent to Rp, and in the case of P1, is the statement saying that the new function symbol has the unique interpretation. Okay. A such that T plus x I, well, the problem is x1 T, T1 belonging to A is consistent. I mean, the point is you are ruling out certain sets A that are problematic because they don't allow for a unique definition of this of the function symbol.
So the spectrum is those set A for which T plus A plus 1 has an AFC.
Yes.
Okay.
Okay. And then we have for the item theorem. Assume
You would like it probably to be all of tau times 2.
well, no, tau times 2 is problematic because of this. You see, if you have a function, if you have a formula for which the theory does not prove for all x, there exists just one y, pxy, this action will be false. Okay, so you certainly can add tau times 0, but you have to be careful in adding the function. But you just consider those for which this makes sense. I mean, otherwise you are assume A belongs to A and C of CFC epsilon delta 0, and I guess that's it. Okay, then
It belongs to the spectrum.
yes,
You say A belongs to AFC.
yes, apologies.
Very particular. Okay.
Okay, and well, apologies, I have to. No, this is not a problem. And sorry, and here I can put T expanding TXT epsilon delta 0. Okay. 1. If TH remains sigma 2 in T plus x I P, P I belonging to A, then CH is not in the, let me call it ANC of T. So this theory T, let's call this T plus T tau A, and here I have ANC of T tau A. Okay, so unless you have reduced pH to a trivial property, you will not put it in the model companion.
If CA remains, why would it not be sigma 2 in this? Because it's sigma 2 in CFC.
Well, because this signature might say that pH is now a sigma 1 sentence.
So, but sigma 1 is contained in sigma 2.
Yes, sigma 2 minus sigma 1. So proper sigma is sigma 2 minus.
Yeah, I
Oh, then okay, then also mean minus boolean of sigma and so on. So like
Yes.
Yes,
So let's say CH is not if CH is not, that's a precise statement. In T for, T plus T tau A for all valid T. Okay, so CH cannot be expressed as a Boolean combination of universal and existential sentence in this theory.
Yes. Or your logician would write it like this because it's clearly not implication in the other direction. CH is AFC implies CH is. But we are logicians, so we understand the concept.
Oh, okay, so you would say if CH is here,
Yeah.
it is in the universal, okay.
But we understand it. Just.
Okay.
It's called modus tollens.
Huh?
It's called modus tollens.
Okay, the same for the pi times c, in sorry. Well, for c in which is I2 in epsilon delta 0 union omega 1. So if you add a constant for omega 1, so here it's a bit more problematic. So if you have a constant for omega 1, then you can run the same argument for any signature which has this constant for omega 1. Vf T plus C implies 2 to the other 0 equal RF. Okay, so this C by itself does not say that continuum is RF2, but with a very, well, actually you don't need even ZFC, you need much less than ZFC, you need essentially replacement. ZFC minus. So if you have ZFC minus, then this formula C, well, actually you also need that C plus omega 1 is first uncountable cardinal implies 0 equals okay, so this is saying that if this C is not in the unity of this theory, and this theory has a constant for omega 1, then essentially the absolute model companion will satisfy the theory for that. If I mean no, it's more like this C, yes, this C will fall in the absolute model companion, so the absolute model companion will satisfy continue with that. And then okay, and note that this D can contain CH, or even can contain to the other 0 equals 3. There's no restriction. Okay, so the point is you are just forbidden to put too many formulas, so to make this statement too simple, and the statement too simple.
So it's a kind of collapse that if you have CH, then this I2 will collapse to sigma 1. Or
no, you
or
don't.
or to this.
No, it's not the case that T plus T implies, because we had the theorem the other time that that the universal and existential fragment is preserved by forcing. So in general, it is not the case. It could be the case that for some choices of the signature, CH implies well. In general, over this theory, you cannot prove that CH is equivalent to, if you have CH, then it is equivalent to sigma 1 sentence. Because, for example, this theory is preserved by forcing. The universal and existential fragment of this theory is preserved by forcing, and CH can be flipped. Okay? And even the universal and existential fragment of this theory, or of this theory, is preserved by forcing. and CH can be free. And I guess
But you see, I have a little bit still trouble understanding what this two is because you say the same. I
So-
struggle to understand one, but then the
Yes.
same for it's because.
so if negation of, so this is C is phi 2. So negation of C is not in the, sorry, C, you're right. So, C is not in T plus T for all when exists. Sorry. Implies not C is not in A C.
Okay. But sorry, why does CH remain CH but psi?
Because
does not-
CH is sigma 2 and psi is phi 2. So CH is the sigma 2 sentence,
Yes.
and psi is the phi 2 sentence. So I have to put the negation.
Okay. And is this 2 to R 0, is it R 2 or R?
Yes, that is true.
Uh-huh. Okay.
And what time is it? Am I done?
1 minute, okay.
Huh?
1 minute, okay.
Okay. Well, this proof is quite trivial, but I don't have time.
What does it say about CH? Come on, what is the?
Well, it says that it says that we have a dichotomy between CH and so that we have that this method selects the signature, selects a value of the continuum, because we have at least one signature which is recursive, such that we are going to put actually both this psi and not CH inside the model companion, because this psi is essentially the coding tricks to give a well ordering of continuum in type L2 in an absolute manner in models of star. So there is a signature, recursive signature, such that you are going to put 2 to the LF0 equal LF2 into the absolute model companion of that theory with respect to that signature, but there is no possible signature in which, if CH maintains the right logical complexity, you are going to put CH in the absolute model companion. So there is a dichotomy. The spectrum, if you inspect the spectrum of all possible extension of PLC plus large cardinals, you will find that inside the spectrum there is a signature such that the absolute model companion of the theory in that signature puts 2 to the LF0 equals LF2 inside, and there is no other signature such that if you maintain the logical complexity is right, you are going to put another value of the continuum inside. Okay, and yes.